Okay, so if you look at the first page, A through D were all very similar. What happened in all of the problems A through D? What's that? The same thing happened in each of them. The middle term canceled out, right. So that's the answer to that question underneath. The middle term canceled. So how come the middle term canceled? What is it about those factors that made the middle term cancel? They have the same numbers and opposite signs. So whenever you have two factors that have the same numbers and have opposite signs, so A through D, you will always have a middle term cancel. And because that happens, we've given these a name. These are called, down here, conjugates. So anytime you have two factors that are the same with a different sign, those are called conjugates. Okay? Now, when you multiply conjugates, you get a special type of quadratic. What did you notice about all the quadratics A through D? They all had another similarity. Right, it was all x or something x squared minus some number, right? What did you notice about the numbers that actually went in there? So the first one you got 4, B you got 81, C you got 49, and D you had 36 and 49. So 4, 81, 49, 36. Those all have a pattern. See? They're all perfect squares. So if we did 1 times 1, we'd get 1. 2 times 2 is 4, 9, 16, 25, 36, 49, 64, 81. Which one did I miss? 121. 12 squared is 144. 13 and 14 are really close. 169 and 196. So this is 13 squared and this is 14 squared. And 15 squared is 225. These are all of the perfect squares up to 15 squared. So if you take two conjugates and multiply them together, you get what is called a difference of perfect squares. So that's the next answer. Difference of perfect squares. Some people refer to it as DOPS, difference of perfect squares. Now the nice thing is, the only way to cancel the middle term is to have conjugates. If the middle term cancels, then you used conjugates. If you use conjugates, then you will have a middle term cancel. Now, having said that, in E, did the middle term cancel? Yeah, you should have gotten 18x squared minus 2, what is it? 242. Okay. Are those conjugates? Are these exactly the same with a different sign? They are. One is 6x minus 22 and the other is 3x plus 11. Are they exactly the same? No. Did the middle term cancel? Yes. Do we have a difference of perfect squares? Is 18 a perfect square? No. Is 224? Or sorry, 242. So why did the middle term cancel? If you look closely enough, you'll see we actually are dealing with conjugates. Lindsay? Good. We could times the right side by 2, and actually what we want to do is divide the other side by 2. Does this factor have any common terms? Any common factors in the terms? I can pull out a 2. If I pull out a 2, what's left? 3x minus 11, and that happens to be the conjugate to this one. So there was hidden inside there a conjugate. Same thing with letter F. What can I pull out of this first binomial? 2 terms. 3x. If I pull out a 3x, what's left? 2x plus 5, which happens to be the conjugate to 2x minus 5, and that's why the middle term canceled. So that fourth question, why did the middle term cancel? It was a conjugate. It was just hiding underneath another number. Okay. So now let's solve some problems. Letter G. What is my perfect square? So x minus 1 and x plus 1. What about H? Y minus 12, y plus 12. That's pretty easy. I? X minus 3 and x plus 3. J is a little bit harder. What times itself is 16x squared? 4x and 4x, and then we have 7 and 7. So this one's going to be 4x minus 7 and 4x plus 7. What about K? Is 3 a perfect square? No. Is 48 a perfect square? No. So can I factor this? How, Kenny? They both have a 3. So I'm going to pull out a 3x, in fact. Do you see how 3 goes into both of them and x goes into both of them? If I pull out a 3x, what's left? X squared minus 16. Now this is a difference of perfect squares. So how would I factor x squared minus 16? X minus 4 and x plus 4. Okay. What about L? What are the perfect squares in L? 2a and 2a minus 5b and plus 5b. Okay? On the next 6 problems, we're going to take it one step further and we're going to find the roots. So, my factors for m are x minus 5 and x plus 5. If those are my factors, how do I find my roots? Set them equal to 0. And then we move this over and we get plus 5, and we move that over and we get minus 5. So it's actually 5 and negative 5, but in math we're lazy, and we just do x equals plus or minus 5. So whenever you get the roots, or the factors, just write equals 0 on both of them and then solve. No, it's actually really easy. So we'll do the next one. X minus 6, x plus 6. So I write equals 0, equals 0. How do I move a negative 6 from the left side to the right side? You add it. So you're left with x equals 6. How do I move a plus 6 to the other side? You subtract it. So my answers are positive, positive, and negative 6. So on O, x minus 10 and x plus 10. So my roots are going to be positive and negative 10. Letter P is a little bit harder. What are my factors for P? 6x minus 10, 6x plus 10. So if I have 6x minus 10 equals 0, how do I get x by itself? Add the 10 plus 10, so 6x equals 10. Now what? Divide by 6, and you used to say 1 and 4/10, but mixed numbers died the death in junior high. We don't do that anymore. Okay, we're going to leave ours as improper fractions, but does 10 over 6 simplify? 5 over 3. So I'm going to simplify this and say x equals 5 over 3. Well, what is the other one going to be? Negative 10 over 6, which becomes negative 5 over 3. So once you find one of them, you automatically know the other one. It's just the opposite sign. Okay? Well, if you had 6x minus 10 equals 0, the goal is to get x by itself. So we move the 10 and then we move the 6. Okay, letter Q. Do I have perfect squares? No. Can I pull anything out? Yes. I can pull out a 3. 3 times x squared minus 25. Do I need the 3? No. You only need the 3 if the instructions say factor. But this says find the roots. So this equals 0. If I divide by 3, if you take nothing and you cut it into 3 pieces, how many pieces do you have? None. So these disappear, and now I just factor x minus 25, which is x minus 5, x plus 5, and that turned into roots looks like just plus or minus 5. So whenever you pull out a number and you're finding the roots, that number doesn't affect anything. But in the next one, we're going to pull something out that does matter. Do we have perfect squares in R? No. What can I pull out? 8 and an x. So 8x, what's left? So 32 over 8 is 4x squared minus 72 over 8 is 9. Okay. Do I need the 8? No. Do I need the x? Yes. So I'm going to erase the 8 and leave the x there. So x times, what are my factors? What times itself is 4x squared? 2x minus 3 and 2x plus 3. Now, because I have 3 x's, I'm actually going to have 3 answers. So every time you have an x, you're just going to write equals 0, equals 0, equals 0. Well, the first one's easy. It just says x equals 0. So that's my first root. What's the root going to be here? Well, how do I move negative 3? Add. How do I remove the 2? Divide. So it's going to be 3 over 2 and negative 3 over 2, so I would just put plus or minus 3/2. Now, I knew this one had 3 answers because my equation was an x to the third. The biggest exponent in your polynomial will tell you how many answers there are. This one had 3, so there are 3 answers. Okay, go ahead and work on the back side. One of the answers is wrong. Look at number 5. On number 5, the answers should say x minus 3 and x plus 3. Change those 9s to 3s on number 5. Other than that, I believe everything's correct.